In this video, I'm going to show how to implement the HashMap or use the existing HashMap collection in Java and use it to replace an array list when we want to do a lookup based on a unique identifier. HashMap is a much more efficient way to go if we have a unique lookup key and we need to find an exact result because it has superior performance or superior algorithm growth rate as the size of the collection increases. Let me explain that through an animation. So I have a previous video where I talk about sets and hash set and how the hash set is an efficient way to store unique distinct objects because objects are stored not in the order in which they were inserted, but they're stored according to their hash code, which essentially is an easy way to look things up. So a hash map is very similar, but instead of just having a set, it actually has two parts. The set is essentially a series of lookup keys that have to be unique. But then the values are mapped to those keys. Map, hash, map. We're mapping keys to values. Where the keys are computed by that hash code, we're mapping them to the values. So the keys have to be unique, but the values don't necessarily have to be unique. Let's take a look here. Let's say that we add a key, which is this gray thing. Now, in a hash map, we can associate that to a value, which is just something where the key can be computed from this value or one of the fields of this value. In other words, if the value is a set of vehicle objects, the key might be that vehicle identification number, which is what we're going to use in this video. So we know that VIN is essentially a lookup for a vehicle. So, okay, we add the red circle to our keys, some other unique object, and we map that to a value that can have many more attributes or represent a much bigger concept than just the key by itself. We add this kind of beige circle to our keys, and we can associate that with the value. Now, here's where a hash map is really cool. Inserts are essentially 0 to the 1 performance because, again, they're not inserted into that key, by the order in which they were created, but instead they're inserted by some kind of algorithm. And that algorithm is going to have the same performance regardless of the number of keys that are stored in that collection of keys. The reason is the algorithm is just saying, okay, given this key, where would I be in this collection? And that's a simple factor of division. And with division, it doesn't really matter how big the collection is. It's nominal dividing by 100 as opposed to dividing by 10,000, which is how we get this efficient operation. Lookups are also efficient because we're taking that key and we're saying, okay, take this key, run it through an algorithm. That will tell me where exactly I can find this key in my hash, essentially in my hash map. And then from that, I can get the value back. So let's see how that works with our animation. We say we're asking for the gray item, and it can directly go to where the gray item is based on this algorithm, and it will return the gray item to us. We say we want the kind of red item. It knows exactly where that red item is in our collection of keys, and it returns the corresponding value to us. Beige, of course, we ask the keys if that beige item exists, and it finds it directly by using this algorithm, and it passes to us the value. So, unlike an array list where we would have to shake hands with every single item and say, are you the car I'm looking for? Does your VIN match? With a hash map, we can say, here's what I'm looking for. And we can give it that key, and then it will just directly give us back that value with very efficient algorithm growth rate. So let's go ahead and implement this in code. We created this inventory reader class a while ago to read vehicles in from a text file. Since we created that, we've added a couple of new attributes to the vehicle, both VIN and also description. So I need to update my inventory txt to include VIN and description. We'll start with VIN. And then we'll put description on the end. I paused the video to save us a little bit of time, and I added VINs for each of our vehicle. Notice that I duplicated a VIN here on the Prius because I want to show what happens in a hash map when we do have two identical keys. And I added a Mustang as well. Now I need to go back to my inventory reader and make an adjustment to what I'm reading. So I've added two new fields. I need to update this if test to make sure we have at least 6 fields. And then I'm going to grab VIN first. Remember, inventory array essentially contains each of these fields which have been read in from that text file. Go ahead and add description as well. Here's where the real difference comes in. Remember, with an array list, we're simply adding things in the order in which we create them. But in a hash map, we don't have a predefined order. We're simply associating items with a key. So that VIN is going to be our key or our unique identifier. So this allVehicles.add is going to change when I change this from a list to a map. So we'll declare the variable as map interface type, and we'll say string, comma, vehicle, because the string represents the unique identifier, which is the VIN. Go ahead and import. Now on the right side, we need to instantiate a new HashMap, because HashMap is a class that implements interface map. So using dependency inversion principle from Solid, we want to store variables as the interface type, but then we need to create an object to put into those variables, and that will be the concrete type that implements that interface, which is the variable type. Hopefully that makes sense. Nonetheless, we will still call it all vehicles. Now down here where we're reading in the data, notice that the add method no longer works because the hash map is expecting two items, the key and the value, not just the value. Well, the key is easy. We know that's going to be VIN, so we simply say VIN, comma, vehicle. It's actually not an add operation. It's actually a put operation when we're talking about a hash map. So little change there, but adding that key and that value is what gives us this map between our key and our value. So at this point, we're populating our map or our hash map with these vehicles associated with a VIN. We need to fill out one other item, which is this fetch vehicle method, which is getting called from our Swing graphical user interface. I created this method earlier but didn't provide the implementation because I didn't have a hash map yet. But now we can retrieve the vehicle from the hash map by using the VIN, and we know this has that very efficient O to the 1 algorithm growth rate, which means that no matter how many vehicles we have, if we're looking it up by that unique identifier VIN, we can simply compute the hash code of the VIN, run that through a quick algorithm, and it will tell us exactly where to find that key and corresponding value in our hash map without having to iterate over the entire hash map. And that's absolutely key to how hash maps work and how they're efficient. So we'll get rid of this to do, and we'll simply return allVehicles.getVin. Easy as that. It's a really simple lookup. Looks like I have a little regression error here. You see that when I previously instantiated this, I would run the vehicles by a certain amount. And with an array list, we only have a collection of objects, where with a hash map, we actually have a map of key to values. We can still iterate over those values, but we need to ask for them. So all vehicles is now a hash map, so I can simply say all vehicles values, and we can still iterate over each of those values. Now, just like an array list, if we're iterating over every single value in a map, that's going to have O to the n performance. In other words, the more items we have to iterate over, which is the n, it's going to take a proportionally longer time to process the whole collection because we have to shake hands with every one of them, and there's no avoiding that. Well, the best way to learn anything in programming is put it in the debugger. So let's take a look at this in the debugger. Notice that when our form loads, the first thing it does is call this inventory reader create vehicle. And I put this together in a previous video so we could keep this one focused on the hash map. But nonetheless, let's go ahead and step in and step over. And you notice that it's reading 4 lines from our inventory file. So it's going to parse these in. The first item it's getting is the Sonic. We'll just remember we have our Sonic 1, 2, 3, 4, 5, 6. Continue to step over this, and now let's see what happens with our all vehicles collection on line 44. So we start with all vehicles is size of 0. Once we create the Sonic, you notice it's size of 1, and sure enough, there is our Sonic. And now we're going to iterate over and read the next item. I'll go a little faster this time. This one is our first object that has that 224466 VIN. So notice that after I finish this iteration, we have another object in here, and we go ahead and loop again. Now this is where things get a bit interesting because this is our second object with that same key 224466. So let's watch very carefully at the end here where it tries to add it to the hash map. Now let's look at what's currently in the hash map. We see something with 2600, and we see something with, 26,000 miles. We see something with 15,000 miles. And the thing with 15,000 miles is keyed off of 224466. So we're currently trying to store something with 16,000 miles in that same location, 224466. Let's see what happens when we do the put. We still have a collection with only 2 items in it because remember the keys have to be unique. So if we try to store 2 different items with the same key, it's only going to store one of them, and in this case it's only storing the last one we entered and overwriting the first one. We could prevent that by doing a check. we could do a contains check to say, does this key exist? And if so, we wouldn't overwrite what's already there. But since I didn't put that contains in, last in wins. Now we're iterating over our final item, which is the Mustang, and we put that in with 113355, and you see that our collection now has 3 items. So I tell it to continue, and here's our form. Now, let's see what happens when I try to load 224466, and I hit search, and you notice that we go to this fetch vehicle operation, where it's simply going to our vehicle's hash map and asking for the vehicle that belongs to this VIN. Remember, that's a very efficient O to the 1 operation, because it's simply taking that key, computing a hash, using that hash to find the key directly in the hash map, regardless of how other many items are there. So I'll take off this breakpoint. I think I'm going to need it again. I'll go ahead and choose continue, and we see that sure enough our form is populated with the information for the second vehicle that was 224466. So you see the second vehicle, 1600.26.7, and sure enough 16,026.7. We could adjust these if we want. I could say 27, and then I could choose save. Now save, it's going to say, okay, am I in an existing vehicle? And the answer to that is yes, so it's not going to create a new object. It's simply going to say, okay, let's go ahead and populate. Turn off some more breakpoints here as I continue to go through this. So we see that we have our first item. Now I could say 1, 2, 3, 4, 5, and that's going to pull up the Sonic, and we can make any adjustments we want to that. We could do 27 miles per gallon. Save, and it's going to save that object and clear the form again. And now if we want, we could create just a whole new vehicle if we wish. So 996633. And we'll make this one, well, yeah, that's fine. We'll make it a Prius, and then we'll say odometer 50,000 miles per gallon, 50 gallons of gas, 3. And we'll say my vehicle if we want, and then we'll choose save. And all of the other operations still work as we wish. I can run each of these vehicles 100 miles. We'll see the odometer on all of them update, and we'll also see the gallons of gas and or battery charge update as well. So go ahead and choose drive. There we have it, 100 added to each odometer and gallons of gas changed. I know I had a breakpoint hit there, so let me try it without the breakpoint. We'll drive 50. We should see each of these increase by 50, and the gallons of gas change as well. And sure enough, you see 50 added here and some of the gallons of gas change, depending on how it rounded and if it was running in electric mode or in hybrid mode. So in this video, we've seen how we can utilize a hash map to make a more efficient essentially add and retrieve operation when we have objects that are associated with a unique identifier. This is an incredibly useful collection from the Java abstract data type collections to use if you do have that lookup need and you want to build a very scalable service so that if your demand goes like this, your performance will stay relatively constant, and therefore you don't have to look at scaling up with actual hardware or anything like that. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.